Good morning. My name is Buzz Phillips. Sorry, I looked at that camera. It's going to be a bad habit. Good morning. My name is Buzz Phillips. I'm the Director of Paper Manufacturing. We're excited to have you here today, and I'm looking forward to showing you around and telling you how paper is made. Our tissue and towel products are made from 100% recycled fiber. This means that we don't use any virgin fiber in our process. Virgin fibers are predominantly made from trees. Recycled fiber comes from the recycle bins, and our fiber is predominantly from office papers, school papers, books, magazines, discarded lottery tickets, posters, and other discarded paper products. The recycled fiber waste paper is turned into towel and tissue products through an extensive process. The first step in this process is receiving and warehousing hundreds of tons of waste paper bales per week. These waste paper bales, like the ones you see behind us, can weigh 1,500 to 2,000 pounds each. They're picked up and put onto a conveyor. This conveyor transfers them into the top of a pulper tub. Think of the pulper as a blender that's 10,000 gallons. Inside the pulper, there's an agitator. Assume the agitator is like the blades inside the blender. We add these bales into the water, and they're agitated or blended into individual fibers and non-paper waste. After the pulping process is complete, the pulper is emptied into a series of coarse screens that take out large contaminants like plastic bottles and long metal wires. And then it's transferred into a tank that we call the pulper dump tank. From the pulper dump tank, we go through a series of screens and cleaners. The cleaners utilize centrifugal motion to allow low density material like the fibers to be separated from higher density materials like heavy staples, paper clips, and rocks. The screens are rotating baskets, and the baskets have small openings in them. Those openings can be coarse openings where we're trying to get out larger contamination like styrofoam, or small openings where we try to get the smaller contaminants like latex material, small plastics, free from the fiber. So we have cleaned and screened individual fibers moving through the process while the contaminants like the rocks, paper clips, and staples are removed and sent to landfill. Our screened and cleaned stock now has to be washed and bleached. So the first step is we dilute the stock down, and then that diluted stock is pumped onto a moving wire in an operation called the vario split. And the water essentially just washes the stock free of latex material and any free inks that are contained on the fiber. From there, we go to a disperger operation. The disperger essentially is two plates that rotate that allow the fibers to come in contact with each other. And that grinding force of fiber to fiber starts to remove some of the inks mechanically. From that point, the stock is put into our bleaching tank. Now, our bleach tank utilizes a chemistry that strips the inks off the fiber. It's important to note that our chemistry and most of the industry has moved to a more environmentally friendly chemistry that strips the inks versus true bleaching, which was done with chlorine dioxide and peroxide in the past. We do not utilize those chemistries anymore, nor does the industry as a whole. The Cordova facility utilizes 350,000 gallons per day of fresh water while we're making paper. While this is a significant amount, it's important to note that our freshwater usage per ton of paper manufactured is significantly lower than the rest of our competition. We utilize water and recycle it numerous times in our process using an operation called clarification. We actually have 3 clarifiers in this facility. In each individual clarifier, we add a small amount of chemistry to the dirty water that we want to recycle. So small, it's measured in parts per million. That chemistry takes the solids and some of the color material out of the water and combines it into a large component that we call a flop. Dissolved air is then pumped into the water stream. and that air rises to the top, carrying the flocks with it. The solids material start to conglomerate on the top of the clarifier, where they're scraped off and removed, whereas the cleaner water is removed from the bottom and recirculated back into our process. The solids that are scraped off of the 3 clarifiers are then accumulated and transferred to the dewatering press. The dewatering press squeezes the water from those solids. That water is actually reused in our process. The solids material, or what we call sludge, is accumulated on our mill property. It's then trucked to one of our 3 farms. On the farms, the soil and the sludge are mixed together. That sludge, or solids material, actually provides a benefit to the soil. It helps to balance the pH, and it allows it to retain moisture. We then farm various crops on our land utilizing this improved soil or enhanced soil from the sludge. This is another way that we reduce our impact on the environment, as a lot of facilities send their sludge to landfill. Our cleaned and brightened stock is sent to one of our 2 paper machines that we have here in our Cordova facility. Specifically, it's transferred to the machine tank. From the machine tank, it then goes through a refining operation. Again, the refiner is very similar to the asperger in that it's rotating mechanical plates that work to fibrillate the fibers. This means that an individual fiber is opened up and has a higher surface area. This increased surface area improves the dry tensile in the finished product. From the refiner, the stock is then diluted significantly, down to 0.2% consistency. This means 2 parts of fiber for 998 parts of water. This diluted stock is then screened one more time to remove any additional contaminants before it enters the head box. The head box then mixes the stock with turbulence, and then it applies it via a jet out of the head box onto a moving wire. This wire is moving at 63 miles per hour in our process. The jet from the head box forces water through the wire, and this is the first part of the drying process associated with the paper machine. After the sheet is formed on the wire, the rest of the process on the paper machine is dedicated to drying the sheet. The first step in this process is that the sheet on the wire is nipped against a thick fabric that we call a felt. The felt and the wire move at the same speed across the forming roll. Water starts to remove from the sheet into the felt through capillary action. The sheet is actually transferred onto the smoother surface of the felt, and then it moves to what we call is the suction pressure roll. The suction pressure roll presses the sheet against the Yankee dryer. This pressing starts to dewater the sheet into the felt. The suction pressure roll actually contains a vacuum element inside it that starts to pull water from the felt that comes from the sheet into the roll itself. Small holes in the roll hold that water until the vacuum is released, and then that water is thrown through centrifugal motion into a catch pan and reused in the process. After the suction pressure roll operation, the sheet is at a 40% consistency. This means 40 parts solids to 60 parts water. So we still have a lot of water to remove from the sheet before we can make our finished product off the machine that we call a parent roll. The sheet has been transferred onto the Yankee dryer from the suction pressure roll. The Yankee dryer is a steam heated rotating element that works to evaporate water from the sheet. In addition to the Yankee dryer, we have 2 Yankee hoods. Inside the 2 Yankee hoods, hot air as hot as 700 degrees Fahrenheit is blown onto the sheet through what we call our nozzle boxes that uniformly distribute the hot air across the entire CD or cross direction of the sheet. In between the nozzle boxes, we have small gaps that allow the evaporated water to be suctioned away from the sheet out of the Yankee hoods. After the Yankee hoods have dried the sheet to essentially a 5% moisture level, what we call real moisture, or 95% consistency, the sheet is then removed from the Yankee dryer with a sharp blade that we call the craping blade. The craping blade, in addition to transferring the sheet off of the Yankee dryer, imparts different characteristics into the sheet depending upon the geometry that we set the blade up at. These quality variables that it can impact are things like softness, thickness, or what we call caliper, and tensile. Once the sheet is removed from the Yankee dryer, it's pulled through what we call a scanner. The scanner is constantly traversing across the sheet. It's measuring both weight and moisture. It's critical that we make process adjustments to keep the moisture and the weight of the sheet at a specific center line. They're both really important for the final quality specifications that we deliver to our customer base. After the scanner, the paper is wound against what we call a reel drum. The reel drum is a motor-driven drum that is pulling the paper and winding it into what we call a parent roll. The parent roll can weigh up to 1 to 2 tons, or essentially 2,000 to 4,000 pounds, and it has a diameter of 60 inches. After the large 60-inch parent roll has been wound on the reel drum, it's kicked out by cylinders to the end of our dry end. A new roll automatically starts building. The finished parent roll, the 60-inch diameter one, is then removed with what we call a clamp truck. The clamp truck takes it to our warehouse, and eventually it's put on a truck and sent to one of our 4 converting facilities. In the converting facility, they take the large roll through a series of equipment and finish it into a usable tissue or towel product. Turning a parent roll into the products that you're used to seeing every day in home and commercial applications is also an extensive process. It begins as our parent roll is unloaded from the truck into one of our 4 converting facility warehouses. The parent rolls are placed onto the unwind stand. Now you can have 1 or 2 parent rolls depending upon whether it's a 1-ply or a 2-ply product. The unwind stand has a motor that helps to unwind what we call the full sheet off of the parent roll to begin the converting process. The first step is that full sheet will go through the emboss section. Embossing is essentially taking the paper through a nipped roll that has a Z-directional structure. The nip pressure embosses or imparts that structure into the sheet. This structure is what you actually see on a towel or tissue roll when you're seeing patterns on the sheet. After the 1 or 2-ply product has gone through the embossing operation, which can impart a variety of different structures into the sheet, the 2-ply product needs to be bonded together. Thus, it goes through a ply bonding station, which allows the 2 plies to be held together. Whether it's a single ply or a 2-ply product, both have to go through a perforation section. Perforation imparts that strip that allows you to tear off 1 or multiple sheets depending upon what the use of the product is. After the full sheet has been perforated, it's sent to the winder. This whole process is taking place at 23 miles per hour. The winder then takes the sheet and starts to wind it onto a core to a specific smaller diameter. These small diameter logs resemble what we're used to seeing in our home, kitchens, and bathrooms. The log is just simply longer. From that point, it's sent to the tail sealer. The tail sealer applies a small line of glue onto the log to ensure that it doesn't become unwound as it traverses through the rest of the process. The logs that are being stored in the accumulator are eventually sent to the log saw. The log saw cuts those logs to specific lengths desired by our customer base. At this point, the product looks and resembles the same products that you have in your home, individual tissue and towel rolls. These individual rolls go to a variety of different conveyor belts, then start to wrap, pack, and palletize the product for our customers for shipment. Buzz Phillips here again. Thank you for walking through our Cordova paper machine facility and made-in converting facility with us. We appreciate you visiting. We hope that you learned something about how paper is made. Specifically, how do we go from waste paper to the finished products that you're used to seeing in your bathrooms and in your kitchens. Is that okay? Or?
Yeah, I can't think of anything to add to that. Perfect.